How's it going, guys? From Motivao. Today we're gonna do a new series of videos for parallelogram proofs in geometry from a special request here in Las Vegas from a student called Esvilena from 9th grade. She's taking honors geometry and she needs help on parallelogram proofs. Okay, so I'm making this special request for her and hopefully it helps her out a little bit more. Okay, so let's start with proofs. Whenever you prove something, and this is for any type of mathematical proof, you have a statement and you have a reason, okay? And that's what makes math so powerful, because you always have to give reasons for any statement that you come up with, okay? Every type of statement, no matter how small or big, has to be backed by some sort of reason, some mathematical reason, okay? And this is very hard for students because it's the first time that you actually do proofs is in geometry, but it's not the only class that you are going to do proofs in the future, okay? Especially if you're taking a very mathematical class. Okay, so let's start. The first thing you want to see is the givens. You're given two things for this problem. First, that PQRS is a what? What does this symbol here tells us? This symbol is the symbol for, you guessed it, parallelogram, right? And it's saying that P, this shape here, PQRS, that's how you read it, that's the order. Whenever you read this letters, it's in the order of how you're gonna write the name of the corners, okay? So PQRS is a parallelogram. That's what's given. We're also given that the measure of the angle P is equal to 70 degrees. So this guy right here is 70 degrees, okay? So what we want to prove, and this is very important to understand, where am I going? Where am I heading? I want to prove that this measure right here, that we don't know yet, is also 70 degrees, okay? So how do I start this? Well, the first thing you want to do is to have a very clear understanding on what properties are out there that you might need, okay? So if we're working with parallelogram, then my intuition says, well, I need to know what are the properties of a parallelogram, okay? And these are some of the properties that are the ones that we learn in geometry of parallelogram. First is the definition of a parallelogram, which is opposite sides are parallel. And then we have opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and the diagonals bisect each other. But you always, besides understanding, having a clear understanding of what properties are out there, you want to refocus your attention on the ones you're going to use. So from all of these properties here in this list, the only one that I'm interested is this third one right here. Opposite angles are congruent, okay? So let's start. The first statement is that PQRS is a parallelogram, right? So we can just write the figure and then write PQRS. And then what is the reason? Well, the reason is that that's our given. That's our assumption. That's another word for the given. It's our assumption, okay? Or hypothesis. Now, what statement can come out of the fact that PQRS is a parallelogram? Well, this one right here, the opposite angles are congruent. So that means that my measure P, measure of the angle P, is equal or congruent to the measure of the angle R, okay? What reason is that? Is the opposite, and I'm going to abbreviate because it's a long word. Opposite angles are congruent or equal. Okay, so this is the symbol for angles. I usually like this one because it's more clear. So measure P is equal to measure R. But that comes from parallelogram properties. But we're not done yet. What other information are we given? We're given that the measure of angle P is equal to 70 degrees. Okay? That's a given. That's again our hypothesis. That's our assumption. Okay? Now, how can we relate these two equalities? Well, to able to relate equalities, we need to use the equality properties. And I have three of them that we might use. First one is the symmetric property. Second one is substitution property. And the third one is transitive property. Okay. Now, in order to use our transitive property, which is the one that we want to apply here, we need to have it in a specific order, right? Because what does the transitive property say? It says that if A is equal to B, so if and B is equal to C, then what? Then A is equal to C. Okay, that's what the transitive property of equality states. But we need to have it in that order. I'm going to use P as A, measure R as B, and 70 degrees as C. Okay? So how do I do? Well, let me rephrase that. I'm going to use measure R as A. This guy is going to be A. This one is going to be B, and this one is going to be C. But in order to have this as A, notice that A is in the first part, not in the second. We're going to use the symmetric property of equality. So measure R is equal to measure P. Okay? This is by the symmetric property. Again, I'm abbreviating, of equality. So with the symmetric property of equality, I can rewrite this with this being first, right? Because I want this to be this A. So now that I have A, B, and C, by the transitive property, measure R is equal to 70 degrees. This is by the transitive property of equality. Okay? And that's how you prove this problem. Okay? Sometimes, let me stop here and say that sometimes teachers will skip this one here, symmetric property of equality, and then just write transitive property / substitution. You might see that also. Okay, that's perfectly okay. That's a reason they're using the substitution property and the transitive property at once. But my style of teaching is that I want to give every single detail to make as much sense as possible. Again, this is the hard part here. I'm going to use the transitive using this as A. So I'm going to change my color because I want to make sure everybody's in the right track. This one here is your A. So this one is A. This one here is your B. This one here is your over here. This one is B, and this one is C. So if A is equal to B and B is equal to C, then A is equal to C. Okay, so that's how I'm using the transitive property, and that's why I use the symmetric property of equality. Thank you again for watching. I hope you enjoyed this video. If you haven't subscribed, please subscribe for more videos. If you have any comments or questions or anything that you want to ask me, go ahead and ask me below, and have a wonderful day.